Okay, so in this video, we're going to look at calculating expected values in your TI calculator. And TI calculating expected values is actually somewhat similar to calculating descriptive statistics for grouped data. So you may also find that helpful to as a video to look at. Now, we're going to go through two worked examples and walk through all of the steps for both of them. Now, in our example, our tickets, we have tickets for a group's fundraiser. They're sold for $1, and one ticket will be randomly chosen, and the winner will receive a $500 gift card to Best Buy. So they expect to sell 1,000 tickets. You purchase one ticket for the fundraiser, find the expected value of your ticket. So on average, essentially, how much would you expect to earn back from your ticket? How much is it actually worth? So this is a very simple case where there's really only two outcomes. So the ticket has a 1 in 1,000 probability of winning because only one ticket is chosen and 1,000 tickets are sold. So our out of 1,000 probability goes here. And then if I win the $500, then the net gain is only $499 because you paid $1 to play. So you get back your $1 and then you get 499 more dollars back. On the other hand, everybody else who buys a ticket, they're just paying in the $1. So that's the negative $1 payout. But then there's a 999 chances out of 1,000 that they're going to get that outcome. So essentially they're going to buy the ticket and they're not going to get anything back. So the way we would do this in our calculator is we would put this data into the list, press stat, which is again the third button on the second row from the left. And then that'll take us to the edit menu. And so just hit enter. This will take us into the lists. And we would want to enter the data from the table in our list. So the gain column would go in list 1 and the probabilities would go into list 2. You can just in these probability columns just type 1 out of 1,000 and it will automatically convert it to 0.001. And you can type 999 out of 1,000 and it will convert it to 0.999. You don't have to do that arithmetic. The calculator will do that for you. If you have data in your list, you will have to clear them. I have another video on entering data into the lists that talks about how to clear the lists that may be useful. Now, once we have the data into the list, then we can exit out of this screen with second quit, and then we're going to do our calculations. We're going to go to the stat button again, but now we're going to scroll over to the calc menu and then again select one var stats. If you're in the older screen or in the classic mode, the one var stats function will come up on the screen. And this is similar to our descriptive statistics case. We'll specify L1, second 1, comma, which is above the 7 key, and then second 2 for the L2 list. This is the list and this is the frequency. If you're in the newer version with the stat wizard on, your screen will look like this. And again, you'll want to specify list 1 as the list, and the frequency list is that list of probabilities that would be list 2, and then calculate. And it will give you your one var statistics. Notice SX, the sample statistics, is blank. When you're entering probabilities, this is considered to be not a sample, but a population, and so this isn't calculated at all. But you can see that X bar is equal to negative 0.5. And if you scroll down, you'll see that there are some additional statistics that are calculated. What does this negative 0.5 mean? It essentially means that on average, you can expect to lose 50 cents for each ticket that you buy. So if we were to repeat this experiment over and over and over and over and over again, and then calculate the average of how much people won or lost, either they won the $4.99 or they lost the $1, that if you calculate this on enough people doing this enough times, the average will be that they will still lose 50 cents. Even though some people will win, most people will lose a small amount. And the average of the big win and the small, many more frequent losses will be that you will end up losing on average 50 cents. Now, here's a second example that is a little bit more involved. So in this case, the manager of our cafe has a staff of 6 wait persons on weekend evening shifts. For the last several years, she has recorded the number of employees who call in sick, and the results are given in the table below. Find the average number of people, the expected number of people of wait persons that will call in sick. So the number of employees that will call in sick, 0 through 4, and then the probability for each of those occurrences. Again, this is collected based on their examples, not derived from some other aspect of the problem, like the raffle tickets. So here we're given there's a 60% probability that no one will call in sick, 20% that one person will call in sick, and decreasing probabilities from there. So again, similar to our previous example, we'll go to stat, and then from the edit menu, we are going to go into the lists, and we are going to enter 0, 1, 2, 3, 4 as our values for list 1, and then our probabilities as our values for list 2. Do make sure that you don't leave out one of these zeros, because that will mess up your calculations. 4% is 0.04, not 0.4, and so forth. Once entered into the list, when we go to calculate the descriptive statistics, the newer version, the Stat Wizard, again, it will look similar to our previous example. We'll specify list 1 as the regular list of where the raw data is, the number of employees, and then L2 is the frequency or probability. On the classic mode, the 1var stats function will come up on the screen, and then you'll enter L1, L2, so second 1, second 2. And when you either hit calculate or you hit enter here, then again, you're going to get a list of descriptive statistics. And this says the expected value is about 0.74. So on average, they can expect 0.74 workers to call in sick. Obviously, on any given night, you're not going to get this value because this is not a whole person, but it suggests that most of the time you are in fact going to get less than one person calling in sick. Or you might look at it the other way. The most frequent occurrences are going to be nobody's going to call in sick or one person is going to call in sick. And although there are circumstances where you may get more than one person calling in sick, the average will be one person or less.